Hi, I am Pradosh Kumar, working as an assistant professor in the Department of Biomedical Engineering from Sri Shanmuga College of Engineering Technology. In this session, I am going to discuss about voltage follower. Voltage follower is an electronic circuit designed using an operational amplifier and has an output voltage equal to input voltage. Why it is called voltage follower? Because its output voltage follows the input voltage. A voltage follower can also be referred as buffer amplifier or isolation amplifier or unity gain amplifier since the gain is 1. The input impedance of an voltage follower is very high. Hence, it is commonly used in several types of electronic circuits where an electrical isolation between the input and output is required. A voltage follower is used for impedance matching so that high impedance source can be connected to a low impedance load. This is the circuit of an voltage follower. In this circuit, we can find the input voltage is given to the non-inverting input and the negative feedback is given. So this is a non-inverting configuration. Voltage follower is connected in a non-inverting configuration. So the voltage gain will be 1 plus Rf by R1. So the voltage follower, if you see this circuit, you can find that there is no feedback resistance connected. Hence, this is considered to be a short circuit. So the feedback resistance value is considered to be 0. Similarly, if we see the input resistance, it is considered to be open. So we can consider the value of the input resistance as infinite based on the ideal op-amp characteristics. So if you see the equation for the voltage gain, Rf by R1, since the feedback resistance is 0, so Rf by R1 will become 0. So substituting that in this voltage gain equation, 1 plus Rf by R1 by Rf, where Rf by R1 will become 0. So our voltage gain will be 1. So V0, we know output voltage is given by voltage gain into input voltage. The input voltage follows the output. That is the output voltage is given by voltage gain into input voltage. Since the voltage gain is 1, our output voltage will be equal to the input voltage. So whatever we are giving as an input voltage, that voltage will be available at the output. So this is the derivation for the voltage follower. So advantages of voltage follower. A voltage follower implemented using an operational amplifier takes almost zero current from the input power source. It has a very high input impedance and low output impedance. A voltage follower gives both current gain and power gain. Voltage follower helps in avoiding the loading effect. Hence, if we want our circuit to be connected to a different impedance, means in that case we can connect our voltage follower circuit so that we can avoid the loading effect. These are the main advantages of voltage follower. Next, the applications of voltage follower. It is used for isolation of input and output circuits. Using this circuit, we can isolate the input and output. It is used as a buffer in electronic logic circuits. So we can use this circuit as a buffer where we want the strength of the signal to be maintained, means then in that place we can use this voltage follower circuit. It is used in bridge circuits through a transducer. Also, it can be used in sample and hold circuits. So another application of voltage follower is it can be used in active filters. So these are the different applications of voltage follower. So this is the waveform of a voltage follower. So see here, when you are giving our input voltage, suppose if I give my input voltage as 1 volt, and if I measure the output, what will be the output means the input whatever I am giving, that will be obtained as the output. So if I give 1 volt as input means then my output voltage also will be 1 volt. Since in this case our output voltage will be equal to the input voltage because the gain is 1 here. That's why it is called as a unity gain amplifier. So these are the different concepts related to the voltage follower. Thank you for listening to my class.